Yeah, good morning. So we'll just wait for 5 more minutes here for the others to join, and we'll start the session shortly. Okay. Hi, Srinivas. Am I audible? Hey, Srinivas, can you hear me?
Yep, able to hear you. Hey, good evening.
Good evening, Srinivas. Let's just wait for 5 more minutes for the others to join, Srinivas, and we'll start the session shortly. I hope the screen is visible.
Yep, it is visible.
Right.
Uh,
Yeah, you were saying
Meanwhile,
something.
can I ask questions?
Definitely, why not?
Yeah, awesome. So the thing is, so how was the market for the cybersecurity? I'm in full stack development for more than I think 7 years. So I've been looking into the grow in a career of in the side of architecture and architecture kind of a thing. So good to know kind of a security, right? So how was the career if I would like to transition into the cybersecurity? How was the career should be like? How it will
Again,
be?
quite booming actually, Srinivas, frankly speaking. So in India right now, there's a lot of demand for cybersecurity job roles. Just to give you an idea about practically, you can go to your browser, and in the browser you can visit this website called jobs.null.community. So this is a website specifically for cybersecurity jobs only. jobs.null.co.in.
Okay.
And you can notice these are all the domains in cybersecurity that you have. Okay. And if you are, well, again, when we learn the course CEH, you can start applying for domains like VAPT, vulnerability assessment and penetration testing, or SOC analysis, or even the freshers job roles. As you can see, as a fresher, there's many postings here, as you can notice. So again, this is a website specifically only for cybersecurity. So again, it's an Indian-based community called null.co. Okay, this gives you an understanding of what job roles are available and how many job listings are there. So again, this could give you an understanding of how in demand it is.
Yeah, got you. And we discussed about the basic, like about the cybersecurity, and all. Along with that, you mentioned like there should be an advancement of looking about the web, where like and completely about the web testing, like website security as well, right? So in the similar
That's a
approach, I'm sorry.
uh-huh. No, go
And
ahead.
the
You were
similar,
saying?
in the similar approach, there is, I hope there is a Windows cybersecurity analyst as well, right? Who actually provides some cybersecurity for a Windows applications kind of a thing, or a console-based application kind of a thing. Am I right? Or correct me if I'm wrong.
There is, yeah, definitely. There is. Again, you are talking about maybe specifically for Windows Server security, maybe.
Mm-hmm.
But again, other than that, there's also something called SOC analysis, Security Operations Center analysis, which deals with any kinds of servers, whether it be Windows or Linux or whatever devices that you have in an organization. You have tools specifically called SIM tools, Security Incident and Event Management tools. So these tools are capable of logging all the information that comes in or goes out of your organization. So whatever logs are generated on all these systems, your Windows servers, your databases, your networking devices like routers, these SIM tools have the capability of fetching all those logs and putting it in one single place with a proper time track. So you get to know what issue occurred at what time on which device. So you have a proper idea of what attacks are happening, what cyber threats are occurring on what systems. So again, doesn't just include Windows. Okay. So yes, you were specifically asking for Windows, but this is an all-in-one approach, I would say.
Yeah, got it. Thank you.
Right. Okay, guys, let's just wait for 2 more minutes for the others to join and we'll start the session. In the meanwhile, if anyone has any questions also, you can let me know. Yeah, go ahead. I can hear you. Hi, Debasmita Das, can you hear me? Perfect. Okay, guys, let's just wait for a minute more for the others to join, and we'll start the session shortly. Okay, guys, let's get started without any further ado. Let me record the session as well. Recording in progress. Right. So in today's class, the first prerequisite class for cybersecurity, we're going to talk about basic networking concepts, understanding what IP addresses are, and more specifically, IPv4 addresses. Okay. Again, guys, again, a very important note. If you have any questions, or if you don't understand something, or if there's any issues with my audio, please do not hesitate to let me know. You can interrupt me at any certain point and place your questions. Okay, so let's get started. Now, when you talk about networking, there are two important definitions to know. One is what is a host, and two, what's a network. Okay, so when you talk about a host is any individual information device. So as an example, your mobile phone, your laptop, your router, a database, a web application server, each of these acts as a host. Okay, these devices are capable of communicating or sending data to other devices and receiving data from them. And when you have a collection of hosts, a group of hosts which are communicating with one another, that forms your network. Now, just like how we in a group of people communicate with one another and address each other with our names, these devices also have such names. And that name is called as an IP address, where IP stands for Internet Protocol. This Internet Protocol was built by the US military in the late 1950s. Right. Okay. So when we talk about Internet Protocol, this was built by the US military in the late 1950s or so. And again, as I've mentioned, there was IP version 1, IP version 2, and IP version 3. These were quite experimental. They didn't work out successfully. What properly worked out was IP version 4. In short, IPv4. Okay. And we still use IPv4 addresses even in today's world. And these IPv4 addresses have a few properties to them. Firstly, it's a 32-bit address. What I mean by 32-bit is that it has 32 zeros and ones consecutively in it. A bit is the smallest data format that a computer understands. Any networking device or any information system on the core level always communicates in the language of zeros and ones. And that language of zeros and ones is called as binary language. So your IPv4 address has 32 zeros and ones consecutively. And these 32 zeros and ones are divided in 4 equal parts, where each part consists of 8 bits. And that 8-bit portion is called as an octet or a byte. And each octet or byte is separated by a dot symbol. So this is what a typical IP address looks like in the binary format. But we humans are not so capable of understanding binary so easily. What we understand are usually the decimal numbers, numbers from 0 to 9. So today we're going to learn how do we convert any binary number to a human readable decimal number. And I'm also going to explain you in a bit why this is necessary for us in networking. Okay. So firstly, before we convert the binary numbers to decimal numbers, let's talk about a few data sizes. So as I've mentioned, 1 bit is equal to 0 or 1. When you combine 8 such bits, that becomes your byte or an octet. When you combine roughly 1000 bytes or approximately 1024 bytes, that becomes a kilobyte. So you might have heard this term kilobyte a lot. Your notepad files or small text files are usually in kilobytes of storage. When you combine 1024 kilobytes, that becomes a megabyte. Your audio files or your images are usually in megabytes of storage. 1024 megabytes becomes a gigabyte. Your huge applications or your movies or any huge video files are in gigabytes of storage. 1024 gigabytes becomes a terabyte. Your device's hard drive storage or external hard drives are in terabytes of storage. And 1024 terabytes becomes a petabyte. We might not have come across petabytes in our day-to-day lives, but they are used by cloud organizations. So cloud storages such as Google Cloud, OneDrive, Dropbox, they store data from millions of users and they have petabytes of storage for such. Okay. Now coming back to our basic binary language, let's talk about converting any binary number to a human readable decimal number. So if we take this number 10101010, and if we wanted to convert this into something which is human readable, there are 2 simple rules for it. Rule number 1 is we need to write down the numbers from 2 power 0 all the way up to 2 power 7 from right to left. So I've written down the number here 10101010, 8 digits, and under each digit you can see I've placed the number 2 power 0, then 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7, from 2 power 0 up to 2 power 7 from right to left. Now you might have a question, why specifically 2 power? Because this is a binary number. There are only 2 possibilities, either 0 or 1. Okay, and once you've written down those numbers, next thing you have to do is multiply the value of the lower number with the top number. Okay, and keep on adding it with the next one. So the values for them to power 0, anything to the power 0 is always equal to 1. It's a mathematical rule. Okay, 2 power 1 is 2, 2 power 2 is nothing but 2 into 2, that's 4, 2 power 3 is 8, 2 power 4 is 16, 2 power 5 is 32, 2 power 6 is 64, and 2 power 7 is 128. Now if you have a number as such 10101010, in order to convert it, I need to first multiply 2 power 0 into 0, then 2 power 1 into 1, then 2 power 2 into 0. So again, let me write it down here. 1 second, guys. Let me just expand this a bit. Yeah, much better. So if I have to convert this binary number to a human readable decimal number, I need to multiply the lower number with the top one and add it with the next one. So 2 power 0 into 0 plus 2 power 1 into 1 plus 2 power 2 into 0 plus 2 power 3 into 1 plus 2 power 4 into 0 plus 2 power 5 into 1 plus 2 power 6 into 0 and plus 2 power 7 into 1. And when we add all that up, we should get the final decimal number. So 2 power 0 into 0, that's 0 itself. 2 power 1 into 1, 2 power 1 is 2, into 1 is 2 itself. 2 power 2 into 0, again 0. 2 power 3 into 1, that's 8. 2 power 4 into 0, that's 0. 2 power 5 into 1, that's 32. 2 power 6 into 0, that's 0 again. And finally 2 power 7 into 1, that's 128. And if you add all this up, 128 plus 32, that's 160. 160 plus 8, 168. 168 plus 2, 170. So when we humans read the number 170, the computer understands it as 10101010, something like high frequency, low frequency, high frequency, low frequency, high, low, high, low. Is that clear, guys? How does a computer understand our language, our numbers, our decimal numbers? And how do you convert any binary number to a decimal number as well? Any questions regarding this up to this point? Ria or Kiran Kumar, Srinivas, Fayaz, Debasmita? Okay, perfect. Now, the reason I'm explaining you all this, guys, the reason that we need to learn the binary to decimal conversions is because from that we can calculate the range of IP addresses. So in order to get the first IP, all I have to do is put all zeros everywhere in the octet. So if I put all zeros in all the 4 octets, and when I convert that to binary, from binary to decimal, I get the first IP as 0.0.0.0. That's it. Because everywhere you just have 2 power 0 into 0 plus 2 power 1 into 0 plus 2 power 3 into 0 plus 2 power 4 into 0 all the way up to 2 power 7 into 0. Everywhere you would have into 0. So the first IP is 0.0.0.0. And if you wanted to get the last IP, the maximum number you could get is by putting all ones. And when you put all ones, it would be 2 power 0 into 1 plus 2 power 1 into 1 plus 2 power 2 into 1 plus 2 power 3 into 1 all the way up to 2 power 7 into 1. So that would be 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128. And that would give you the number 255 if you calculate. And the last IP from that, what we can deduce is 255.255.255.255. So your IPv4 range always starts from the first IP 0000 and goes up to the last IP 255.255.255.255. You would never have an IPv4 address about the number 255. Reason being, when you logically convert all ones from binary to decimal, the maximum number you could get is 255 only, not more than that. Okay, so that is why you would never see an IP like this 300.256.400.10. This is an invalid IP. This will never exist. A valid IP would look something like this 192.168.0.10. This is a valid IP address, okay, because all the numbers fall between the range 0 and 255. Okay, now you know this is the first IP, you know this is the last IP. What about the IPs in between? Okay, what about the sequence of those IPs? So in order to understand that sequence as well, there are 2 simple tools again. Okay, but before we continue with that, any questions, guys? Please do let me know if the audio is not fine, if I'm going too fast, or if I'm going too slow. Any questions up to this part? Srinivas, Kiran, Fayaz, Devasmita, Mohan, Vamsi. Okay, assuming no questions, let's proceed further. Let's talk about the sequence of IP addresses. Now, to understand the sequence again, there are two simple rules, guys. Rule number one, always start with the rightmost value. What I mean by that is if this is our first IP, 0, 0, 0, 0, the next IP would be 0, 0, 0, 1. The rightmost value will increase or increment by 1. Next IP 0, 0, 0, 2. Next IP 0, 0, 0, 3. Next IP 0, 4. Next IP 0, 5. Next IP 0, 6. This goes on all the way up to 0, 0, 0, 254 and 0, 0, 0, 255. Now, once you reach this maximum number, can we have a number like 0, 0, 0, 256? Is this possible? Definitely not, because every octet can only go from number 0 to 255. It cannot exceed more than that. So that is why when then comes rule number 2. So only after the rightmost octet has been completely filled, then you go to the left value. So this 0 now changes to 1, and the rightmost octets reset back to zeros again, or wherever you have 255, those become 0 again. So now what happens again after 0, 0, 255, then you have 1, 0. Now don't directly jump after 10 to 20. That would be wrong. Remember rule number 1, always increment the rightmost value first. Okay, so after 10, you would have 1, 1. After that 1, 2. After that 1, 3. After that 1, 4. 0, 0, 0. I mean sorry 0, 0, 1.4. Then 0, 0, 1.5. Then 0, 0, 1.6. Then 0, 0, 1.7. This goes on all the way up to the value 255. Once it reaches 255, it becomes 0 again, and this next one becomes 2. So whatever cycle repeated here from 0, 0 to 0, 255, from 1, 0 to 1, 255, same cycle repeats again from 2, 0 to 2, 255. Same cycle repeats again from 3, 0 to 3, 255. Again from 4, 0 to 4, 255. From 5, 0 to 5, 255. From 6, 0 to 6, 255. 7, 0 to 7, 255. And again 8, 0, 0, 0, 8, 0 to 0, 0, 8, 255. Again 0, 0, 9, 0 to 0, 0, 9, 255. Again 0, 0, 10, 0 to 0, 0, 10, 255. Like that, it keeps on going all the way from 2540 to 255, I mean 254, 255, then 2550 to 255, 255. So 2550, 2551, 2552, 2553, all the way up to 255, 255. Now, once both these octets are filled, then what happens? Next 0 changes to 1. So whatever cycle repeated now from 0, 0, 0, 0, all the way up to 0, 0, 255, 255, same cycle repeats again from 1, 0, 0 to 1, 255, 255. So the 0 changes to 1. And then again, you have them from the very beginning, 0, 0, 0, 1, 0, 2, 0, 3, up to 0, 255. 1, 0, 1, 1, 1, 2, 1, 3, up to 1, 2, 5, 5. 2, 0, 2, 1, 2, 2, 2, 3, up to 2, 2, 5, 5. Like that all the way up to 0, 1, 2, 5, 5, 0, 2, 5, 5, 1, 2, 5, 5, 2, 2, 5, 5, 3, up to 2, 5, 5, 2, 5, 5. And once both these are filled, this 1 changes to 2. So again, if you notice the cycle here from 0, 0, 0 to 0, 2, 5, 5, 2, 5, 5, 1, 0, 0 to 1, 2, 5, 5, 2, 5, 5, 2, 0, 0 to 2, 2, 5, 5, 2, 5, 5. Again, after that, 3, 0, 0 to 3, 2, 5, 5, 2, 5, 5. And then 4, 0, 0. Oh, sorry. Then 0, 4, 0, 0 to 0, 4, 2, 5, 5, 2, 5, 5. And somewhere down the line, you'll have 0, 2, 5, 5, 0, 0 to 0, 2, 5, 5, 2, 5, 5, 2, 5, 5. So as you can see, if I go on the bottom, you have 2, 5, 5, 0, 0 to 2, 5, 5, 2, 5, 5, 2, 5, 5. Once all these three octets are filled, then this 0 finally changes to 1. And the remaining 255s become zeros again. Now, whatever repeated from 0, 0, 0, 0 to 0, 2, 5, 5, 2, 5, 5, 2, 5, 5, same cycle repeats again from 1, 0, 0, 0 to 1, 2, 5, 5, 2, 5, 5, 2, 5, 5. From 2, 0, 0, 0 to 2, 2, 5, 5, 2, 5, 5, 2, 5, 5. From 3, 0, 0, 0 to 3, 2, 5, 5, 2, 5, 5, 2, 5, 5. And finally, from 2, 5, 5, 0, 0, 0 to 2, 5, 5, 2, 5, 5, 2, 5, 5, 2, 5, 5. Here's the first number and here's the last number. the last IP address. Okay, so that is how the IPs are cycling from the first IP till the last IP. Now, if I had to ask you a question, how many IPs do you think you have in total? You could just calculate with the simple permutations and combinations formula. You have 4 octets, each octet is revolving 255 times. So since there are 4, you just type 255 into 255 into 255 into 255, and that would give you 4.3 billion IP addresses. So in the complete range from the first IP till the last IP, in the last 10 minutes, we have gone through 4.3 billion IP addresses. So when these IPs were built in the late 1950s or 1960s, they thought 4.3 billion IPs are more than sufficient for the rest of eternity. Because back then there was no proper internet. There were not many devices, there were not many websites, there were not many organizations which had computers much. Okay. But fast forward to 2023, the population today itself is 8 billion people. And each person, even a small kid, has a phone in his hand which needs an IP address. So again, if each person has multiple devices for 8 billion people, you would have multiple IPs again. Okay, so each person, if he needs 2 devices for 8 billion people, you would need 16 billion IPs. But we only have 4.3 billion IPs here. That is why on the midway, they came up with a solution. First solution was dividing these 4.3 billion IPs into some certain categories called classes, class A, B, C, D, and E, and a subcategory called public and private IPs. We'll talk about classes in the next session, guys, but let's talk about public and private IPs in today's class. Okay. So if I have to explain how the IPs have been categorized, how the 4.3 billion IPs have been categorized, I can show this with a simple diagram. So let's assume this whole huge box is my 4.3 billion IPs. So let's assume this huge rectangle is the whole IPv4 range, IPv4 addresses from the first IP till the last IP, which is 4.3 billion IPs. Okay, so these 4.3 billion IPs have been divided in 5 categories first, called classes. So again, this huge box is divided in 5 smaller boxes, as you can see. Okay, and each of these boxes can be called a class. So this is class A, this is class B, this is class C, this is class D, and this is class E. And again, in each class, you have a subcategorization. Some IPs in class A are called public IPs, some are called private IPs. Same thing for class B and same thing for class C as well. In class D and class E, you don't have any private IPs. All of them are public itself. So you have a few public IPs in class A, a few private IPs. Similarly, a few public IPs in class B and a few private IPs. Similarly, a few public IPs here and a few private IPs here. And in class D and class C, there are no private IPs. All of them are public IPs itself. Okay, so this is what simple categorization of the whole 4.3 billion IPs looks like. If you want, you can make a note of this, guys. Okay, the simple diagram shows you how IP addresses, all those 4.3 billion IPs, have been divided. Okay, any questions up to this point, guys? Anyone? Srinivas, Fayaz, Debasmita, Vamsi. Again, guys, it's let's keep this a two-way session rather than just a one-sided. Please do interact. If you have any questions, I mean, if there are any, I can clarify them. I can explain it in a much better way or an easier way to make you understand it. Okay. So, any questions up to this point? Right. So let's conclude the session with one last thing, understanding what public and private IPs are. We'll talk about classes in tomorrow's session, guys. Don't worry. I'm going to explain about classes in the next session. Let's talk about public and private IPs. And to explain that, I'm going to take the example of our home networks itself. Okay. So usually in your home network, what happens is you have a Wi-Fi router to connect to the internet, right? And to this Wi-Fi router, let's assume this circle is my Wi-Fi router at my home. Okay. And this Wi-Fi router is connected to all your devices internally. So in your home, you could have a laptop, you could have a smartphone, you could have a smartwatch, you could have a smart TV. All of these devices are connected to your router. Oh, just a second. Yeah, let's say a smartwatch here and a smart TV here. Okay. And when you want to communicate from this device to the internet, your router gets a connection from outside your house. So you might have an optical fiber cable coming from outside your house from an organization called ISP, Internet Service Provider. So in India, we have ISPs like Airtel, Act Hibernate, okay, or Idea, okay, Hathway. All these are ISPs, Internet Service Providers. They are organizations which provide you the service of internet, and that is provided with something called as a public IP. A public IP is an IP which is provided by the ISP to connect to the internet or the public network. Okay, so when your phone wants to communicate with a website like google.com, let's say there's a server here called www.google.com. How does this happen? Let's say if you're connecting to Google from your phone first sends a packet to your router. From the router, the packet goes to the ISP, and from the ISP, the packet goes to google.com. So over here from router to ISP, it is happening with public IP. But how does your phone communicate with the router? Through the private IPs. So each device in your network, guys, in your local internal network, let's assume this box is your internal network. Each device in your network gets a private IP. So your router also gets a private IP. Let's say PR1. Oh, let me move this a bit. Yeah, so your laptop gets PR2, private IP2. Your phone might get private IP3. Your smartwatch could get private IP4, and your smart TV could get private IP5. Okay, and all of these are connected to one another through the Wi-Fi network. Okay, so let's say this line denotes the Wi-Fi connection. Okay, each of these devices is connected to the router wirelessly. Okay, so whenever any of these devices wants to communicate internally in the intranet network, they use the private IPs. So the packet first comes from private IP3 to private IP1. Okay, and from private IP1, the packet jumps. Router has two interfaces. So it tries to transfer the packet from a private IP to the public IP. And from here, it goes to the ISP. And from the ISP, it goes to google.com. So public IPs are the IPs used to connect over the internet. Private IPs are the IPs used in your intranet. Intranet is your local network. Okay, so that intranet IPs, private IPs, can be given by you yourself, or it can be given by a DHCP server. Okay, what is that DHCP server? We'll talk about that in the next class. Okay, in our home network, the Wi-Fi router itself acts as a DHCP server. So in our home networks, the router itself provides the private IPs. Okay, and the public IP is always given by the ISP, Internet Service Provider. Okay, again, very important to note, guys. Public IP for public network, internet network. Private IP for private network, intranet network, local home network. Okay, is that clear? Any questions? So again, a quick recap on what we have learned in today's class. Firstly, can I clear these drawings, guys? I hope everyone has taken a note of it. Can I clear these drawings? Again, I'm a terrible artist, guys, so sorry if the drawings are not so great, but you'll have to make do with this. Bear with me. So now, again, a quick recap of what we have learned in our session today. First, we have learned about what IP addresses are, what is IPv4 address, what are the properties of IPv4 address, how do you convert any number from binary to decimal. From that binary to decimal conversion, we understood the range of IPs. What is the first IP? What is the last IP? After the range, we try to understand the sequence of IPs. What is the first IP? What comes after that? What comes after that? What is the sequence? From that sequence, we got to know how many IP addresses do we have in total. And once you knew that these IPs are not sufficient, okay, in that scenario, we understood what is the solution for that. What is NAT, network address translation, what are public IPs, and what are private IPs. Please explain the scenario in case of a phone, as most of the times you're getting public IP. Phone in the sense I'm assuming that you're talking about the mobile data files. When you are talking about mobile data, your SIM card, which is given to you by an ISP itself again. So if you're using an Airtel SIM card or a Jio SIM card or whatever it is, that SIM card gets a public IP from your ISP again, the provider who has given you that SIM card. Okay. So again, in your SIM cards, when you check the public IP, it might be slightly different from what I've shown you here. It might be a much more updated version of IP address. It's called IPv6 address. But basically, when you connect from your phone, connecting using mobile data, your SIM card fetches a public IP from the ISP again. So if you're connected with a Geo SIM, your Geo SIM fetches the public IP from the Geo satellite, or from the closest Geo tower. Okay, and that public IP will be an IPv6 IP through which you can connect to the, again, various websites on the internet. I hope that clarifies. Any other questions, Fayaz? Right. So yeah, that's that, guys. Nothing further in our session today. So we have learned quite a few important concepts. In the next class, we'll talk about classes A, B, C, D, and E. Why do we have these classes? What is the necessity of these classes? Okay, how they are different from one another. And we'll also talk about a few important protocols. What is DHCP protocol? What is DNS protocol? What are special IPs? Okay, we'll talk about all that in the next session. Okay. So yeah, that's that, guys. Nothing further. I'm going to exit the session now, and I'll see you tomorrow at the same time. Please join using the same link. Okay. Bye bye. Good night. I'll see you soon.